Okay, here we're getting into deeper water. We'll find out if the boat comes with us.
Adam and Jamie have already tested and busted the movie myth that an upturned rowboat can be used as a makeshift submarine.
Well, that didn't work at all.
But for all you science geeks out there wanting a more in-depth explanation of buoyancy, then Eureka! This is for you.
Let's talk buoyancy.
Okay, well, Archimedes defines it as a body that is partly or entirely submerged in a fluid. Well, let's just say buoyancy is the tendency of an object to float.
And in our case, the buoyancy of a boat is determined by how much water it displaces or pushes out of its way.
Yeah, and that water, say a cubic foot of it, is about 64 pounds.
That means every cubic foot of water that our boat displaces gives it an extra 64 pounds of buoyancy.
Yeah, and if that's still not clear enough for you, have a look at this.
Cut to the graphic. Cut to the graphic.
Okay, so let's get this straight. Buoyancy is the upward force produced by liquid, in this case water, on an object, in this case a boat, in which it's immersed. The buoyancy acting on the rowboat is equal to the weight of the water that it displaces. And the dinghy is designed to displace enough water to keep it and at least 5 burly pirates afloat. So it has no problem keeping Adam above water. But when the rowboat takes on enough H2O...
Here comes 46. And... yeah, that's it. Now it's coming over the side over there.
the weight inside the dinghy is equal to the force of the buoyancy pushing upwards. One last bucket and...
oh, now it's going. There it goes.
I'm clearing the bow there.
Oh, the bird.
The buoyancy is beaten and the boat is sunk. More? You want another in-depth buoyancy factoid? Okay, here you go.
I want to point out what happens to a pocket of air when you're underwater. The deeper you go, the smaller it gets. This red mark is how much air I had at the surface. Watch what happens when I go down. See how it gets smaller?
Yep, at the deep end, the air pocket inside the tube gets smaller. And that means...
So as that pocket of air changes size, it means that its buoyancy is also going to change, very dynamically depending on what depth you're at. So as you're moving over a topography, you don't have one neutral buoyancy. It depends on how deep you are, which means that boat is going to be very, very hard to control.
And there you have it. The laws of physics don't lie, just the movies.